Hello everyone, welcome to my channel. So we are in today organic chemistry. That is a topic today. I am going to explain about the aromaticity. Aromaticity, yeah. So you probably see this following type of questions. So identify below the questions which one is aromatic, which one is anti-aromatic, and which one is non-aromatic. You probably see these questions in a competitive exams, as well as who are learning this organic chemistry initial stage. This is the most important. First one is GOC and second one is aromaticity. So if you know that which one is compound is aromatic, which one is compound is non-aromatic, which one is anti-aromatic. So one question, I think one lecture is enough for this complete understanding of this aromaticity. When you are listen carefully in this lecture, you can see I given that difference between anti-aromatic and non-aromatic. If you see here, aromatic compound, it should be cyclic and it should be a planar. Okay, it should be in a planar. So it is in a conjugated. If you have any conjugation, so we can call it as aromatic compound. So conjugation is nothing but only not double bond, not only double bond, lone pair also it is going to comes under a conjugations. And it should be in must and should spt hybridizations. It is in must and should spt hybridizations. And this is the foremost important, it obeys the Huckel's rule. It obeys the Huckel's rule, that is in 4n plus 2 pi electrons. Okay, 4n n is equals to 0, 1, 2, 3. You can get 2 pi, 6 pi, 10 pi, 14 pi, like that. This is for what? Aromaticity. As it is same for the anti-aromaticity, but the change is it obeys the Huckel's rule, but here 4n pi electrons, it follows the 4n pi electrons, it follows the 4n plus 2 pi electrons. This is the major change of this aromatic compound and anti-aromatic compound. I hope you understand aromatic and anti-aromatic, right? So if you see the non-aromatic compound, non-aromatic compound, non-aromatic in the sense it is a cyclic or acyclic. It should be an cyclic, it should be an acyclic, but it is a non-planar, it is a no planar, it is not a, one plane, it is a no planar. So here you can see it will follow the sp3 hybridizations, not in sp2. Sp2 is comes under aromatic and anti-aromatic. When it is the people will give the sp3 hybridizations, then we can see non-aromatic compound. It's do not follow any rule. Okay, it's do not follow any rule of this non-aromatic. I hope you understand. It should be a cyclic, planar, conjugated sp2 hybridizations. Obeys Huckel's rule. 4n plus 2 pi electrons is aromatic. 4n pi electrons is anti-aromatic. If you see benzene, I think all of you know that aromatic compound, everyone knows that aromatic compound is nothing but benzene. If you see in this benzene, so here you see this carbon, it is a sp2 hybridization, right? So I think all of you know that one bond equal to 2 electrons, am I right? So here how many bonds are there? 3 bonds equal to 2, 6 pi electrons, right? 6 pi electrons, 3 into 2, 6 pi electrons. If you see this 6 pi electrons, here we have a 6 pi electrons, am I right? So in this compound is called as aromatic compound. So this is for what? Aromatic compound. So I will give one trick for this. I identified aromatic compound and anti-aromatic compound. Very simple trick. If you know this trick, so you can easily write which one is aromatic, which one is anti-aromatic, which one is non-aromatic. So I am going to give the tips to you. The trick, you can see this trick. So if you have a double bonds, odd double bonds, then you can call it as aromatic. If it is a even double bond, anti-aromatic. I hope you understand, right? If it is a R double bond, you can call it as aromatic. If it is a even double bond, if you can call it as anti-aromatic. So if we are going to look some examples so that we can understand which one is aromatic, which one is non-aromatic. So I am going to give some examples to you so that you can understand easily this aromatic and anti-aromatic. If you see this, I am going to give examples to you. First one, second one, third one, fourth one, fifth one, sixth one, seventh one, eighth one. So if you see this example, so that you can understand what is that aromatic and anti-aromatic, non-aromatic. So let us look at that first one. So how many bonds are available here? One bond. One you can see here. This is one sp2. This is the sp2. But you can see here sp3. When it is present in a sp3, I said before it should be a non-aromatic compound. So non-aromatic. So coming to the second one. Second one is nothing but this bond is migrated here and this bond is, so you will get here positive charge, right? So it is in sp2, it is in sp2, it is in sp2, but how many bonds are available here? Two bonds. Two is nothing but even is nothing but it is a anti-aromatic compound. Coming to the here, you will get positive charge, here you will get negative charge. So it is a sp2, it is a sp2. How many bonds are available? Only one bond is available. So what is that one bond? It is a aromatic compound. If we coming to the in this one, so here we have a one bond, here we have a negative charge. So in this negative charge also we are going to consider. Why? Because it is a negative charge in the sense it is a electron density. So here we have a one electron density. Here we will get positive charge. Positive charge is not get any electron density. Negative charge as well as lone pair of electrons. It's having a electron density. So we are going to consider those things also. So here we have a two bonds, right? Two bonds equal to anti-aromatic compound. And if you see in this one, here we have a lone pair of electrons. This bond is migrated and this bond is migrated, this bond is migrated. It is a conjugation. But how many bonds are available? 1, 2, 3. Three bonds. Three bond is nothing but aromatic. If you see this one, here also we have a lone pair of electrons. This bond is migrated here, this bond is migrated here, this bond is migrated here. So how many bonds are available? Three bonds. Three is nothing but odd. Odd is nothing but aromatic compound. And if you see here, one bond, two bond, three bond, minus negative charge also, it is having a electron density, so that we are going to consider this negative charge itself, right? So 1, 2, 3. 3 is nothing but odd. Odd is nothing but it is aromatic compound. And coming to the here, only one bond, it is sp2, sp2. One bond is available, so it is a odd. Odd is nothing but we will call it as aromatic compound. And you can see here how many bonds are available? Two bonds. Two is nothing but even. Even is nothing but anti-aromatic compound. Yes, this is for what? Aromatic, anti-aromatic, non-aromatic. When you have a compound containing sp3 hybridization, so you will say that this is the non-aromatic compound. If you have any even odd even double bonds, so you can call it as anti-aromatic compound. If it is a odd double bonds, you can call it as aromatic compounds. Very simple. I hope you understand this aromaticity. Thanks for watching this video. Thank you everyone.